Scooby-Dooby-Dooby-Doo! Where's Scooby Snacks? Right here, Shaggy. Whoa, Scooby Snacks are so good. Woo! Oh, they're all gone. What the? All right, thanks for being here, you guys. Let's see here, helping you with 2.1, right? 2.1. You behind the screen. Don't forget to do what? What? Don't forget to pause me. Don't just watch it all the way through. Right? People fail that last test, won't say their names, because they just watched the video and didn't pause me and try it on their own. Try it on your own. Then push play and see how you did. So number 1, PEMDAS, parentheses, exponential, multiplication, division, addition, then subtraction. So 7 plus 8 is 15. And 25 minus 15 is, pause me. Good. Try this one on your own. You're going to have to get a common denominator. Do you know how to get a common denominator? The common denominator. You're going to multiply them by each other to the top and bottom. Multiply them by each other to the top and bottom. So multiply 4 up here, and then multiply 3 to the top and bottom. That'll get you a common denominator out of 12, and you can combine those. Solve for h. Well, we got a 2 pi r next to that times by h there. So you could probably just divide that sucker, right? Just divide it to the other side. Look, I solved for h. Way-o. Ooh, so that's good review for composition. Plug one function into another, as well as times. Do you remember how to do times? That's some good review there from last unit, unit 1. Okay, so then we got number 5. So I'm going to show you the easy way and the more difficult way, but still works for you. You choose whatever method you want, and then just keep practicing at it and get really good at it, okay? So for example, the easy way for number 5 is our vertex. And so our vertex is these two values. That's our vertex. So it's called our h and k value, or whatever letter it says in the book. So I think, I could be wrong, but I think in the book it tried to use like values like c and d or something like that. Yeah, I tried to say our c and d value. I like to call it the h and k value. It's basically just your x and y value. Basically your x and y value. Okay, now watch out. The left and right, it's opposite what you think. So this -2 for the vertex is opposite. So you think left 2, but it's actually right 2. It's actually right 2. And then it's actually down. It's actually down 3. So the vertex is right 2, down 3. Right 2, down 3. So go right 2, down 3. Good. There's our vertex for our graph. Now the easy way to do this, if there's not a number in front, right? If your a value, if there's not a number there, right? If a just equals 1, then you can do it this way. And what you can do, according to our parent function, you can go right 1, and 1 squared is just 1, so up 1. So right 1, up 1. Then you can go left 1, up 1. And there's the start of your parabola, your quadratic, graphing your quadratic equation. So then, what else can we do? Well, we could go right 2. And what is 2 squared? Well, 2 squared is 4. So now, from the vertex, we can go right 2, and we can go up 4. So right 2, up 4. So right 2, so that's 1, 2, up 4, 1, 2, 3, 4. And if you can go right 2, up 4, and it's a quadratic, that means it's got symmetry. And you can also go left 2, up 1, 2, 3, 4. And so there is our parabola. There's our quadratic there. There's our quadratic there. Beautiful. What's our symmetry, or axis of symmetry? Well, the easy way to find it is, let's look at the vertex. Because it's just the x value, of the vertex, right? Right there at 2. Let's do a different color for you. So that's a line, and that line is called the axis. It cuts it, it splits it right down the middle like your face. So axis of symmetry. There we go. So that's our axis of symmetry. That's x equals 2. Good. Of course, this one is x equals -2 because it's opposite what you think. Whoa, that's even. Don't do it, Newbold. Stop. Oh, yeah, you practice on that. Okay, beautiful. Erase, erase. Whoa, whoa, you practice. That's you practice. Well, you need to practice on the videos, too. So pause me. Can you finish the rest? Do you remember in class how to find the domain and range? Pause me. Pause me! Try it on your own. Try it on your own. Okay, so the domain for all quadratics, as we go left, we do see a value up, because it just carries on forever. So that's going to be to the left is negative infinity, and to the right is positive infinity. Now the range is a little bit trickier, right? The range is a little bit trickier. So the range, so the domain is left to right, but the range is down to. You should write this on your paper. It'll help you. So it's down to up. So here we go, down to up. Ready? So pretend that's like my pencil or a stick. Am I on the graph yet? No. Am I on the range yet? No, no, no. Oh, now I am right there. What number is that? What number is that? So right there is -3. And of course, that's our vertex. So the range is going to be our vertex. And so technically, it's y equals -3 to, technically, y equals what? Well, -2, -1, 0, 1, 2, 3, 4, to infinity. And so it's -3 to infinity. In math, we like to be all like, ooh, look at me. I'm making it all shorthand notation to confuse everybody else. I don't know why they do that. Whatever. So it's going to be, so the final answer there is just -3 to infinity. But I made a mistake. And I might have made a mistake during class, first period. And that mistake is that we include the -3. So this actually needs to be a bracket. This actually needs to be a bracket. B-R-A-C-K-E-T. And that means we need to include. Right? It starts at -3 and we include -3. Now infinity we can't include because it just keeps going on forever. Okay, sorry, just talking too much during class today. So there's our domain, and there's our range. So now pause me, and you try number 6. Try number 7. Try number 8. Give each one of those a try. Okay, so here's number 7. Here's number 7. So I like to teach with transformations, but if you want to go old school on me, you can. And that's doing an XY table if you want to. So an XY table is going to be a little old school. But we can show it to you. We can show it to you. Let's go old school on you. Ready? Here we go. Old school. So old school is where you do like an XY table, basically. And it can be a little bit trickier, a little bit more complicated, but some people really like it. And most of my career, I loved it until I started teaching it, and then I got lazy. And I started teaching transformations, which is easier, so do it. Okay, so you do need a vertex to make it easier to do the old school with the table. So what's our vertex again? What's our vertex? Say it out loud. You say it. What's the vertex? Good try. Did you get it right? Let's see. Remember, it's opposite. It's opposite. So it's actually a +3 and a +1. So the y value stays the same, but the x value, that actually changes. The x value is opposite. Opposite sign. Opposite sign. Okay, so our vertex is going to be right 3, and then it should be up 1. So right 3, up 1. Okay? So what we're going to do now is we're going to take that whole equation and use it over and over and over and over and and over and over and over and over again, doing some crazy calculations. I'm going to show you that the transformation is easier. You'll see. But you can do it old school. Okay, so we need to choose a value to the left of our origin and to the right. A couple values. So what's to the left of 3? Well, 2 and 1. So we put a 1 and 2 there. What's to the right of 3? What's to the right of 3? So to the right of 3 is 4 and 5. And so those are our x values that we're going to go ahead and plug in now. We're going to go ahead and plug those in. Those are our x values to plug in. Good. So I'm going to take the whole equation now. -2, blank, -3 all squared, plus 1. Well, what was the blank? The blank originally was the x. But what's actually our x value? Our x value, what's our x value? Our x value is a 1. Okay, so let's go ahead and work that out. So 1 minus 3 is a -2. So we get -2 times -2 all squared plus 1. -2 times -2 is a +4. Times this -2 over here, bring that down. And that's going to be -8. And -8 plus 1 is -7. So we actually get a -7 now for our y value. I should have pushed that over, but that's okay. I'll put it over here. So 1, -7 is a coordinate. Then we put a 2 in there. Right? We put a 2 in there. And this should equal 1 when we get to 3. Okay, so put a 2 in there. So then we go -2 times, we'll make it red to show you the difference, what we're doing there. So we plug, right? We go ahead and plug a 2 in there. -3 all squared plus 1. So 2 minus 3. So 2 minus 3 is a -1. And -1 squared is a +1. Times the -2 is a -2. Plus the 1 is negative. Oh my goodness, that's -1. So we go -2. Wait, that doesn't seem right. Does that seem right? So 2 minus 3 is -1. -1 squared is +1. -2 plus 1, -1. Yeah, I guess so. So then we get a 2. We get a -1. Good. And then we plug a 3 in. 3 minus 3. Oh, so if we plug that in now, again, we're plugging it up here, right? So -2, 3 minus 3 all squared plus 1. Oh, so 3 minus 3 is 0. Squared is still 0. Times -2 is still 0. And so that's just going to be 0. And we still have a plus 1. So that's why it's 1. That's why it's 1. So we're going to go and do 3, 1. I feel like I made a mistake on this one, though. Did we make a mistake? Let me see. Oh, okay, that's -7. That's why. That's not -2. Oh, yeah, because that was part of the formula, so it's actually -7. Okay, so we're going to go, let's see here. Oh, what does that mean? What does the negative mean, you guys, when there's a negative there? What is the negative sign? What does the negative sign mean on the outside of the function? So what does it mean? It means upside down. And as you can see, when we start to graph it, we're going to go 1, -7. So 1, -1, 2, 3, 4, 5, 6, 7. What's next? What's next? We go over 2. We go over 2, down 1. Then we go 3, +1, which is our vertex. So we go over 2, down 1. And look at that. What did the -2 make it do? The -2 made it go left 1, down 2. That means this one's going to be right 1, down 2. We should also get a -1. And if you plug a 4 in there, it works. Because 4 minus 3 is 1, and 1 squared is 1, times the -2 is -2, plus 1 is -1. So that works there. And wouldn't you know, you're probably going to get -7 down here as well. So we get a -7 to start off with for our parabola. If it lets me, there we go. So we get a -7, then it goes -1, then +1, and then -1, -7. So wow, it'd be nice if we just knew a transformation, wouldn't it? Well, we go 5 comma negative 7. You want me to show my work? Okay. Equation is y equals negative 2. We're going to plug in a 5 for the x value. You want to see that negative 7? Let me show you. 5 minus 3 is 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 1 is negative 7. Yep, so we are down here. Okay, so we're going down. We're going down. That looked terrible. Try it again. We're going down. And we're going down. There we go. There's our graph. Try to round it if you can. Make it more round up there. Okay, good. Okay, so again, our axis of symmetry is just right here. Axis of symmetry at 3, because that's our 3. That's our vertex, remember? Our domain, all real numbers to the left and to the right, but the range is different. You remember how to do the range? So the range, we take our pen. Remember, it's down. The range is down to up. So we're going like this, and we're going knee, 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 down to up, knee, 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 down to up. And so, oh, we're already on the graph. We're on the graph here and here and here and here and forever. Forever. And so, whoa, wait, come back. Oh, here it is. So now we're going to go from negative infinity, right? From negative infinity, going up to negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. What's that number? A positive 1 is where it starts, which is our vertex. Our range is our vertex. But this time when we go down to up, it's negative infinity, finishing at a hard capped 1, a hard capped 1 there, right? So we're going to go and finish there at the 1, the 1. Y value equals 1, and so that's where we're going to be there at 1. So that's our range. That's our range. So thanks for watching. Make sure you watch my next video. Thanks for watching. So you can do transformation or an XY table. As you can see, the transformation is a lot easier, right? Over 1, down 1, over 2, down 4. Or there's the slope there, which makes it tricky. But you'll get it, you'll see. Ask questions in class too. Bye for now, see you soon. Don't forget, go to your local store, buy some Scooby snacks.